Okay, so we have a hemispherical bowl is filled with water, and the volume of water required to reach different water levels is given in the table below. Alright, so we have the height, which is this thing here, h, the height of the bowl, and we have the volume, the amount of liquid or water that it can hold. Now, because it's hemispherical, let's just talk about the context of what that means. That means it's half of a circle or half of a sphere. So if we got another bowl, we could put it on top and it would be a sphere. Okay, so the diameter of this sphere then, or this half sphere, is 40 centimeters. So what's the radius? Well, the radius is half the diameter, okay, which means the radius would be 20 centimeters. Okay, that length there would be 20 centimeters. Which means the maximum height that we can really measure as well is also 20 centimeters. Okay, so the first thing we want to do is obtain a scatter plot. So I've already inputted my data into the list in your statistics menu, and then what we want to do is graph that. Okay, and make sure you're graphing list 1 and list 2. Alright, and it should look something like this. Now, in some of these problems it will tell you which model to use. In some of them we need to assess just by looking at the R squared value. Okay, just by looking at the correlation, which model has the highest correlation. So we're told a cubic model, we need to find the cubic model. Alright, so we can calculate x to the power of 3. That's the cubic model. Now, it is of the form ax to the power of 3 plus bx squared plus cx plus d, and we're given all those values, a, b, c and d. Okay, so what we need to do is write those down. Just write them down to 3 significant figures. Okay, so we have minus 1.028 028 x to the power of 3 plus 62.1 x squared, and then we have plus 7.07 x and take 1.19. Okay, so that's our cubic model. Alright, use the model to find the volume when the bowl is full. Okay, so what we're going to do is we're going to copy this model. Alright, we press copy and it opens up our graph function, and we just press execute to paste it in there. Okay, so now if I go back into my graph, that model should be there. Okay, and we can graph that. It'll say, it does this all the time, it says condition error. Okay, say exit, just go press the cross arrow to go into it and it'll graph it for you. I don't know why, it's some silly error. Now we want to find the volume when the bowl is full. Now the bowl's full when the height is 20 centimeters, okay, or our x value is 20 centimeters. So we're just going to do a y calc. Alright, when x is 20, y is equal to, so the volume when the bowl is full, 16,751 milliliters. Okay, so I'm going to write that one here, 16,751 milliliters. Now that occurs when x is 20, or when the height of the bowl is 20. Then they might have some problems like this where they say the volume of a sphere is given by this. They give you the formula for the volume of a sphere. Use this to check your answer. Okay, well, we have a sphere, it's got a radius of 20, but this is a half sphere, so let's put it into the formula and see what happens. So we have 4 on 3 pi. Now I'll put that in brackets just so you guys can see what's happening. We've got 4 on 3 times pi times radius to the power of 3, and the radius is 20. I'll put that in brackets just to get our bed mass right. Okay, now this would be the volume of the whole sphere, but we're dealing with a half sphere, so let's divide it by 2. 16,755 compared to 16,751. It's pretty close. Okay, so that's all you have to do. Use this volume to check your answer. Yeah, they're pretty similar, they're about right. The next part is use the model to estimate the volume of water when the height is 10 centimeters. Okay, so again we're just G solving. What is the volume of water? So we're y calcing when x is 10. Okay, 5,251 millilitres.